Hi. So let us understand what is a chain rule and how it is used in differentiation. Now, before moving on to this, we should know the basic formulas of differentiation. These are some basic formulas that you should know before moving further. And also we have studied about the UV rule and the U by V rule. We'll just have a quick example based on UV rule. Now, we have to find the derivative of sine x into e raised to x. Now, the first term is taken as u and the second term is taken as v. Now, in UV rule, we write the first term and we take the derivative of the second, plus we write the second term and the derivative of the first. So, it is sine x into derivative of e raised to x plus e raised to x into derivative of sine x. Now, what is derivative of e raised to x? It is e raised to x plus e raised to x, as it is derivative of sine x is cos x. And if we want, you can take e raised to x common and this will be your final answer. This is how we apply UV rule in differentiation. Now, let's look at this function. Now, this function looks similar to the previous question, but this question contains a function within a function. So we have e raised to x inside a function sin x. Now, how it is solved? Now, as you can see, what is derivative of sin x? It's cos x. So the derivative of sin e raised to x will be cos e raised to x. But x is replaced by e raised to x. Hence, we'll get an extra term that is into derivative of e raised to x. So now, what is derivative of e raised to x? It's e raised to x. Hence, the answer is cos e raised to x into e raised to x. Let's have a more complicated example. Now, derivative of log tan x. Now there is a function log and inside log there's another function tan. So first we need to take the derivative of log. Now what is derivative of log x? It's 1 by x. So the derivative of log tan x will be 1 by tan x. Now as x is replaced by a new function tan x, the extra term will be derivative of tan x. And what is derivative of tan x? That you already know, that is sec square x. So your final answer is sec square x upon tan x. Let's look at another question. Derivative of e raised to tan of 3x square. Now there are three functions involved. The first one is e raised to x, the second is tan x, and the last is the polynomial function, which is 3x square. Now first, we know derivative of e raised to x is e raised to x. So the derivative of e raised to tan 3x square will be the same, e raised to tan 3x square. But x is replaced by tan 3x square, so the extra term will be derivative of tan 3x square. So the first step is solved. Now the second step, the first term remains the same. Now we know the derivative of tan x is sec square x. So derivative of tan 3x square will be sec square 3x square. As x is replaced by 3x square, the extra term will be derivative of 3x square. And derivative of 3x square is 6x. So this is our final answer. So this is how the chain rule is used. You can have two functions, one inside the other. You can have three functions, or you can have more than three functions as well. So here are some questions which you can try on your own.